Hello, my dear students and the real ISRO aspirants, and it is one of the most demanding dream job for most of you. I wish all my ACE Academy and ACE online students and all the serious aspirants to really crack ISRO exam and working in such great organization as a real electrical electronic engineers. Based on this, artificial intelligence, you're talking about satellite communication, defense sector. Okay, it's a dream job, right? Okay, so all the best. Now, myself, I'm PS Krishna Varma, faculty in electrical engineering in ACE Engineering Academy since 2009 and ACE Online. Now, the main intention of this 1 hour revision course is to inspire you. I know the truth that in 1 hour we cannot do any wonder, but at least if I can inspire you, if I can ignite you, okay, to go ahead with confidence, that is more than enough. So first thing I want to say is don't give up. Until you come out of the exam hall from today until, I think September 14th is exam, right? Okay. Until you come out of the exam hall, until you give up the last bit, don't give up every day, okay, day and night, do hard work, sir. Because don't worry about how many posts are there, how many are writing, but the true quality will always win. So the first suggestion is don't give up. Until you write the paper, last bit, until you give out, don't give up every day. Don't worry about what you don't know. Worry about what you know and how better you can perform to beat the competition. Okay? Yes. Now the main intention of this program is, yes, this is a course revision for ISRO exam and myself, BS Krishna Varma. And by subject, as you know, it is electric circuits or network theory. Okay, so both EEE, ECE, we give these names. And as far as syllabus is concerned, it is almost GATE. Yes, most of the syllabus is not most. I say 100% it is GATE syllabus. Okay, you see for electrical, my subject starts with network elements, ideal voltage, current source, dependent source, RLC, M elements. Now here M is not something, M is mutual inductance piece. Okay, that comes in magnetic circuits with dot convention, you know that. So RLC and M. And network solution methods, KCL, KVL, nodal and mesh analysis, okay, network theorems, of course, every theorem. In that is specifically mentioned Thevenin's Norton superposition, maximum power, transient response of DC and AC networks, sinusoidal steady state analysis, resonance, two-port networks, balance three-phase circuits, star-delta transformation and complex power and power factor. This all comes under electrical syllabus. ECE, everything is same except three-phase, okay, and you have more frequency domain. Now this is ECE people, of course, more post are for ECE, of course. Circuit analysis we call node and mesh analysis, superposition, Thevenin's theorem, Norton's theorem, reciprocity, sinusoidal steady state, phasors, complex power, maximum power transfer theorem, time and frequency domain analysis of linear circuits, RL, RC and RLC, solution of network equation using Laplace transform, linear two-port network parameters and star-delta transformation. Okay, Y delta is star-delta. Okay, so I told now, sir, syllabus is same, exactly matching like GATE syllabus. The standard of ISRO paper is also like GATE, but little bit less calculations. So compared to GATE, ISRO, problems are very good, but calculations are minimal. Okay, calculations are not as tough as GATE. That is the first thing I want to say, but good quality. So again, I always suggest what to study, sir. No magic, no wonder. Our ACE Academy PYQs. So our ISRO PYQs are also available, and also our GATE and IES PYQs are more than enough. So in this available 10 days, 20 days, just to do GATE PYQs, IES PYQs and ISRO PYQs, that is more than enough. No need of any textbook, etc. There is no time, sir. No need also. Okay, chalo. Now let us talk. Now my intention of revising is I will carefully build, okay, every model, okay, and go ahead with the revision. Okay. So I have got all the sub chapters here. So in the process of discussing this 1 hour, the typical models I am going to talk. So reduction technique, definitely 2 bits are coming. In ISRO, out of 8-10 bits in networks, 2 bits are coming in reduction technique itself. So be careful. Now here the question is the equivalent resistance seen between terminals mentioned. So what is the resistance seen between these two terminals? Now first of all, this structure is a very famous structure known as bridge structure. Yes or no? Because in a bridge structured network, no two elements are series nor parallel. Are these two parallel? No, sir. I know current will come. Yes, I know. Yes, we know that current will come. Okay. Yes, current will come. I know it divides. But can you say these two are parallel? No. Because there is a cross arm element. There is a cross arm element. So don't say they are parallel. If they were parallel, reduction would have been very faster. No, they are not parallel. So first of all, this is a bridge structure. And in a bridge structured system, no two elements are series nor parallel. Then what to do? You have to do star delta or delta star. You can convert one of these delta into star or one of these delta into star or the star into delta, the star. Anything you do, you will get the answer. But another observation is, in a bridge structure network, if the product of opposite arms are equal, then the bridge is said to be balanced. If the product of opposite arms are equal, then the bridge is said to be balanced. 1 into 6 is equal to 2 into 3, 6. 1 into 6, 6. 2 into 3 is also 6. So bridge is balanced. This is a balanced bridge, sir. Balanced bridge network. Now what happens in a balanced bridge network? In a balanced bridge network, when you give energy, energy means voltage, the potential of this point and the potential of this point are equal with respect to any other third point. The potential of this point and the potential of this point are equal with respect to any other third point. Because it is equal with respect to any other third point, current will not flow through this. And because current cannot flow, I can treat it as open circuit. Now when you treat this as open circuit, now these two become series 4, in parallel to these two become series 8. These two series 4, these two series 8. So 4 in parallel to 8, that is 32 by 12, that is 8 by 3 ohms is the answer. Answer is 8 by 3 ohms. Okay, it is simply 8 by 3 ohms. Okay, na? So that is the answer, because here bridge is balanced. Now see this model. Okay. Now here again he is asking the effective resistance. Now this structure is also bridge structure. Again no two elements are series nor parallel. Okay. Now is the bridge balanced here? No. Here 1 into 3 is not equal to 2 into 3. So bridge is not balanced. This is not a balanced bridge. This is not a balanced bridge. Then what to do if it is not a balanced bridge? You have to compulsory convert one of the delta into star or star into delta. So I better convert this delta into star, because there are 3 equal resistors. Now 3 equal resistors in delta, the corresponding value in star is by 3. So if I convert this delta into star, okay, between this node and this node, this becomes this into this by this. So 9 by 9 1 ohm, 9 by 9 1 ohm, 9 by 9 1 ohm. So I convert one of the delta into star. Then you see I remove this delta. You see now these two are in series 2. Okay, 2 is in parallel to 3, because after converting this delta into star, these two become 1 1 series 2, 2 1 series 3, these two are parallel, plus 1 ohm, another 1 ohm. This is the answer. So this is 1 plus 6 by 5, answer is 11 by 5 ohms. Okay, answer is 11 by 5 ohms. Okay, that is the first thing. Now see this question. What is resistance RAB? Here is asking resistance RAB. Okay, resistance in between terminals A and B. Now if you look between A and B, now we are finding resistance. Resistance is passive property. Na? Resistance is what property? Passive property. So remove the active element. Which is the active element here? Ideal voltage source. So remove the active element, ideal voltage source. So removing ideal voltage source means short it. This you have to short. So if you short this, now see this ideal voltage source short, I will replace with a wire like this. And however, this is 3 and this is 6 and this is 2 and this is 2. These are the two terminals A and B. So this is 3, 6, 2 and 2. So when you are finding resistance, as you know, resistance is passive bilateral property. As resistance is what? Passive bilateral property. Deactivate the source. What is the source here? Ideal voltage source. Ideal voltage source, short it. If it is a voltage source ideal in reduction, short it. If it is a current source ideal, open it. So I short it. This is what will come. Now if you observe, these two are parallel na? 6 in parallel to 3 plus these two are in parallel na? 2 in parallel to 2. So 6 in parallel to 3, 2 in parallel to 1, 2 plus 1, answer is 3 ohms. Answer is 3 ohms. Okay. So when you are finding resistance, deactivate the source, because resistance is passive property. Ideal voltage source, short it. 6 in parallel to 3, 2, 2 in parallel to 1, 2 plus 1, 3 ohms. Answer is how much? 3 ohms. Okay. Now see this model. Now suddenly here I am also asking what is the resistance RXY. Again I am asking resistance between X and Y, but this time current source is there. Ideal current source, what you have to do? Open it. Ideal current source, open it. Ideal voltage source, short it. Ideal current source, open it. When you open it, now this becomes a redundant element. So when you open this element, current cannot flow. So 5 ohms also won't come into picture. And when you look from here, these two are in series now. 3 is in parallel to 6. So 1 plus 2, 3 is in parallel to 2 plus 4, 6. Answer is 2 ohms. Answer is 2 ohms. Answer is 2 ohms. Okay. So when you look from here, 2 plus 1, 3 is in parallel to 6. Okay. 3 in parallel to 6 is how much? 2 ohms. Okay. Because this time current source, open it. Voltage source, short it. Okay. Chalo. Now what is this resistance R? Looking from here. What is this resistance R looking from here? Chalo. What is the resistance R looking from here? Now it is looking confused. Okay. When you encounter such confusion, you rearrange and reshape the network, and that process is called node shifting technique. What we call this process? That process is called node shifting technique. So let this be A terminal, let this be B. So this resistance is the resistance in between A and B. Okay, resistance is the resistance in between A and B. Now this junction A same until here A. This junction B same until here is also B. It is the same node, please. It is the same node, no confusion. So this junction A, this is junction B. So that means there are only two nodes. I am rewriting. So let this be A, let this be B. Okay, chalo, one A to B 3 ohms. Okay, one A to B 3 ohms. Another A to B is also 3 ohms. Another A to B is also 3 ohms. And another A to B is also 3 ohms. Now 3, 3, 3 parallel. Answer is how much? 1 ohm. 3, 3, 3 parallel. Answer is 1 ohm. Okay. So 3, 3, 3 parallel. Answer is how much? 1 ohm. That is 1 ohm. Okay. So when you encounter such networks which are not simple, you do rearrange. Okay. That concept is called node shifting. Okay. This is entire A. This entire B, I rearranged and I wrote, and it is all parallel actually. There is nothing like short circuit, they are parallel. Now see, this is an interesting ISRO question, sir. This is an ISRO old question, okay? 2007 paper, but easy question. Options I am not giving, chalo. What is current IX? He is asking current IX. Now, is there any short circuit here? No, don't think there is a direct short circuit here. If pure passive element short, it would have been shorted, but here, because of this wire here, there is a potential difference coming here. This is at higher potential. This is at lower potential. Okay. See, this point is at higher potential. This point is at lower potential. So potential difference exists. So current will flow here. Yes or no? Potential difference exists and current will flow here. So don't say no, it is shorted. So again, we are confused with the way it is arranged. So again, I will do node shifting. So what I will do? Let this be A. A. Same wire. This is also A. Let this be B. This is B. Same wire. This is also B. So finally, you are looking between A and B. A and B. Finally, you are looking between A and B. Chalo, one resistance, 3 ohm between A and B, another resistance, 3 ohm between A and B, another resistance, 3 ohm between A and B. Okay? And you are giving how much? 24 volts between A and B. 24 volts between A and B. Okay? You are giving how much? 24 volts between A and B. Now, A is at higher potential, B is at lower potential. And we know current always flow from high potential to low potential. So if you observe 24 by 3, this is 8 amperes going down, 8 amperes going down, 8 amperes going down. Okay, you gave 24 volts, 3, 3, 3. So current always flow from high potential. But he is asking Ix from B to A. He is asking current Ix from B to A. Actual current is going from A to B. You know the effective resistance is also how much? When 3, 3, 3 parallel, effective resistance is only 1. So 24 by 1, total 24 amperes will come, and that 24 will divide as 8, 8, 8, 3, 8 amperes. But you know current always flow from high potential to low potential in a passive element. But he is asking current Ix from B to A. But A is at higher potential than B, na? So actual current is going from A to B, but he is asking current opposite to the reference. So Ix is minus 8 amperes. How much is Ix? Answer is minus 8 amperes. Okay? Not plus 8, minus 8. Why it is minus 8? Because the reference direction is opposite to practical. The reference direction is opposite to practical. Now this is a very important model, sir. In ISRO, this model came 2 times. In ISRO, this model came 2 times. What is R equivalent? Okay, he's asking what is R equivalent. Now, this is going up to infinity, the mathematical model, like a long transmission line. See, what does this model physically represent? Maybe it is very long distance, single phase 2-core cable, like line, neutral, where every kilometer is lumped into 2 ohms, 2 ohms, 2 ohms, 2 ohms, like that up to infinity. And this is the leakage resistance for every kilometer, like that. So 2 ohm, 2 ohm, 2 ohm up to infinity, 2 ohm, 2 ohm, 2 ohm up to infinity, and this is the leakage resistance. Chalo, now he's asking what is R? What is the R? Chalo, what we will do now? Let us mathematically model. So this is my target terminals. Now this periodic pattern repeats itself. This will repeat itself. This will repeat itself. This is repeating itself. Okay, this is repeating itself. So if you observe, if this is R, this is also R. Okay, if this is R, this is also R, because infinity plus and minus infinity. Na? If this is R of the entire infinite ladder network, even you remove one segment, this is also R. So lump it. That is approximation here. So if this is R, even you remove one segment, this also should be R, because infinity minus 1 is infinity. Because in mathematics, infinity is such a large number or such a large valued number that you add or remove anything in a finite will not affect the value. Like if this is R, remove one segment, this also should be R. So I am modeling this as R. So this network becomes something like this. This segment I separated. Okay, this is a periodic segment. So this is the actual R I want, which is 2 ohms, 2 ohms, 2 ohms. Now this also I lumped into R because infinity minus 1 is infinity. So this also should be R. Chalo, this is the approximate mathematics. Why I will say approximate? Because lump it. So now let us mathematically model it. Now this R value is equal to, these two are in series. Okay, 2 plus 2, how much? 4. 4 plus, these two are in parallel. That is 2 in parallel to R. So this R is equal to 4 plus 2R by R plus 2. Now if you cross multiply, R square plus 2R, okay, take LCM and cross. R square, so here 4R, 8, 4R plus 8 plus another 2R. Remove 2R, 2R. So finally the quadratic equation is R square minus 4R minus 8 equal to 0. Chalo, let us solve this. So I got the quadratic equation as R square minus 4R minus 8. Chalo, now if you solve for R, now this R is minus B plus and minus root of B square minus 4 AC. A is 1, C is minus 8 by 2A. So if you observe, this is 4 plus and minus root. This is 32, 16, 48 by 2. Again 48, 16 into 3 na, 16 means 4 plus and minus 16 root is how much? 4 root 3 by 2. So R is 2 plus and minus 2 root 3 ohms. Chalo, 2 plus and minus 2 root 3 ohms. But here we know when all elements are linear passive bilateral. Okay, when all our elements are linear passive bilateral. Please understand, okay? When all our elements are linear passive bilateral, the answer cannot be negative, please. Okay, when all elements are linear passive bilateral, you know, in a linear passive bilateral, the Ohm's law curve come from quadrant 1 and quadrant 2 in VI plane. See, in our VI plane, okay, generally our VI plane, if all are linear passive bilateral, then the quadrants are 1 and 3. So slope is always positive. So resistance must be positive. So mathematics gave some answers, sir, but physical interpretation is equally important. I solved this with mathematical modeling. I got some answer, but physical interpretation is equally important. How can you take negative? When all resistors are linear passive bilateral, you know the Ohm's law characteristics appear in quadrant 1 and 3. When Ohm's law characteristics appear in 1 and 3, slope has to be positive. Yes or no? Slope has to be positive. That means resistance should be positive. So that is why finally negative is discarded. So R is 2 plus 2 root 3 ohms. Chalo, that is the answer. Okay, another famous model, infinite ladder, be careful. Now see, this is a very famous model, sir, I am repeating this. Okay, now I need RAB. It is called cube problem, and here he is asking the resistance between the opposite diagonal corners of the entire cube. So any two opposite diagonal, RAB. Now here the actual idea is symmetry, okay, where path resistance in all paths are equal. Now you travel from A to B, you go in any path, resistance will be equal, like 1, 1, 1, 1, 1, 1, 1, 1, 1. So due to which what I can do, I can divide the current and write KVL, but you remember, this is a very standard model. Remember the answers are, when the resistance is opposite diagonal corners, RAB will be, okay, 5 by 6 into R, remember. If it is reactance also 5 by 6L, if it is impedance also 5 by 6Z. But if all are capacitors, it is 6C by 5, remember. If it is the same capacitor CAB, it is 6C by 5, 6C by 5. If it is resistance, yes, 5 by 6R. If it is capacitance, 6C by 5. Okay, remember that. So for resistance, reactance, impedance and inductance, 5 into that value by 6. Per capacitance, conductance, susceptance and admittance, 6 into that value by 5. Okay, remember. Okay, that you remember. Of course, capacitance is in farads, resistance is in ohms. You know that, but you remember. Now, very famous, sir. See, I will tell at the end, I want to give the details of my phone number and all the registered students. Okay, all my registered students in the next 2 weeks, 3 weeks. Okay, you can personally contact me. I will give my details. What specific doubt you have got in our material, you post to me in my WhatsApp. I will reply immediately on priority basis for you, because I know ISRO exam is approaching and I will do my best. Don't worry. But I will give that at the end. Then, now this is another question which also came. Okay, what is RAC this time? Previously, what is RAB? Opposite diagonal corners of the entire cube. But what is RAC? They are the opposite diagonal corners of one of the meshes, not the entire cube. They are the opposite diagonal corners of one of the mesh. So this is like surface, opposite diagonal corner. This surface, RAC, RAC, or here this surface, RAC, 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 anything. So RAB is the complete opposite diagonal corner of the entire cube, but RAC is the opposite diagonal corners of the surface of the cube, face of the cube. Okay? Okay? Or the mesh of the cube. I can also say like a mesh. Chalo, TK. Now in that regard, yes, if you observe, okay, now here also if you do, but here current division is not possible as path resistance in all paths are not equal. Here current division is not possible. What is the reason? As path resistance in all paths are not equal. Then mirror image symmetry we apply. After applying mirror image symmetry, we join such nodes which are at same potential, and from that we get this RAC as, you remember? Yes, 3 by 4 R ohms, 3 by 4 R ohms. Okay, it is 3 by 4 R ohms. However, if it is a capacitance, if it is CAC, it is 4C by 3 farad. 4C by 3 farad. Okay, resistance 3R by 4, capacitance 4C by 3 farads. Okay, 4C by 3 farads. Remember, so resistance, inductance, impedance, and reactance. Okay, resistance, inductance, impedance, reactance are 3 into that value by 4. But capacitance, conductance, admittance and susceptance is 4 into that value by 3. Okay, that you remember. Okay, now another. This also came in ISRO exam, sir. What is RAD? See, some formulas better remember. There you don't have time to derive and prove it. What is RAD? But here RAD are the any two adjacent terminals of the cube. RAD are the any two adjacent terminals of the cube. So any two adjacent terminals, RAD, 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 RAD like that. So these are the any two adjacent. Here also current division is not possible because path resistance between AD in all paths are not possible. Then what we should do? Here also mirror image symmetry and join such nodes which are at same potential, and if you do that, you will get this RAD as, yes, 7R by 12 ohms. Okay, and if these are capacitors, CAD will be 12C by 7 farads. That is 7R by 12, and this is 12C by 7 farads. You will get how much? 12C by 7. Okay, that you remember, 12C by 7 farads. Okay, that is CAD. Okay, 12C by 7. RAD is 7R by 12 and CAD is 12C by, yes, 7 farads. That will be the case, that you remember. That will be the case. Okay, so remember, if it is opposite diagonal corners of the entire cube, 5 by 6 into that R value. If it is a capacitor, 6 into that value by 5. If it is RAC, opposite diagonal corners of the surface, 3R by 4, or capacitors 4C by 3. If it is any two adjacent terminals of a cube, 7R by 12, or if it is capacitor, 12C by 7. Remember, sir, standard, very standard. Okay. Chalo, now, sir, another model. What is the resistance RAB? Here, what I am doing extra now, I took a dependent source. Yes, this is a problem with dependent source. Now, whenever you encounter problems with dependent source, this dependent source cannot work on their own. Okay, this cannot work on their own. They themselves require energy from independent source. If you give this Vx, that will work. But if there is no energy, it won't work. And moreover, dependent sources have internal sub-circuit resistance. Dependent sources will have internal sub-circuit resistance. Please understand, what is this dependent source? Dependent sources will have internal sub-circuit resistance, and that we have to consider. So in such case, what to do? We apply Ohm's law. In such case, we apply Ohm's law. Give voltage, find current, or give current, find voltage. So what I will do, chalo, let me give a current of 1 ampere. I am applying Ohm's law now because that resistance we don't know. So let me give a current of 1 ampere and find voltage across it. Of course, voltage across itself is Vx. So now according to Ohm's law, this RAB will be voltage by current. Voltage is how much? Vx. Current is how much? 1 ampere. Okay. You can take even 1 ampere, 10 ampere, or your lucky number, doesn't matter. So ratio of voltage by current is answer, na? So this Vx by 1 is the answer. So let us find Vx. But when 1 ampere is in series to all elements, current through every element is 1 ampere. So when 1 ampere is going through one, this is 1 volt, this is 2 volt, and this is 3 volt. And I am writing a KVL. So if you write a KVL, minus Vx plus 1 plus 2 plus Vx by 2, okay, yes, yes, Vx by 2 plus 3 is 0, okay, minus Vx plus 1 plus 2 plus Vx by 2 plus 3 is 0. If you take Vx by 2 is 6, Vx is 12 volts. So once you got Vx, this RAB, okay, this RAB will be Vx by 1 na, so 12 by 1 12 ohms, 12 by 1 12 ohms, okay, 12 by 1 12 ohms, okay, that is the answer. Now see this next question, sir. This model came 2 times. One of the model, another model also I will do. What is the effective resistance seen by the voltage source? What is the effective resistance? Now what is the difference here? Now this is completely different. Thevenin's resistance is called open circuit resistance under de-excited case. Thevenin's resistance is called open circuit resistance under de-excited, remove all the sources. But effective resistance is the resistance offered by the network while working. So effective resistance is the resistance offered by the network to the source while working. Now we should not remove anything, sir. As it is, when it is working, we have to find. So what is the effective resistance? So I need R effective. R effective is the resistance offered by the source while working. Now we should not remove anything, as it is we have to find. For that again I will apply Ohm's law. So it is 18 by I total. Let us say this is I total. So the effective resistance seen by the voltage source is the resistance offered while working. That is 18 by I total. Okay, that is what I want. Chalo. Now if you observe, this is 18 by 3, how much? 6 amperes. 18 by 6, 3 amperes. And that is however 9 amperes. So if you observe, 9 plus 3 plus 6. So total this is also 18 amperes. 18 amperes. So total it is 18 by 18. 18 by 18. Answer is 1 ohm. Answer is 1 ohm. Okay, answer is 1 ohm. Okay? Yes, answer is 1 ohm. Okay? So if the question was Thevenin's resistance or open circuit resistance, you know, then deactivate and do. For that what we do? Yes, then this is the target terminals, current source open, then 3 in parallel to 6 would be 2. But here what is asking? Effective resistance. Thevenin's resistance or open circuit resistance is 2, but effective resistance is the resistance offered while working. And how much it is? While working, it is only based on Ohm's law, because we are not removing anything and deactivating. It is only 1 ohm. Okay, please understand, it is only 1 ohm. Now see this question, sir. Interesting question. What is this voltage V0? What is this voltage V0? Now he gave 2 networks A and B. Some elements are connected and is asking V0. Okay. Now in this regard, are these elements parallel? Now don't misunderstand. This is one network, this is one network. Internal connections we don't know. See, these internal connections we don't know. These internal connections we don't know. So are these elements parallel? No, they are not parallel, because their internal connections we don't know. They are not parallel, please. These elements are not parallel. Okay. So don't misunderstand, they are parallel. Then what to do? Let us apply KCL. Now see, when 10 volts is across 5, this is 10 by 5, 2 amperes. When 10 volts is across 2, 10 by 2, 5 amperes. Now if you apply KCL, 5 and 2, total 7 entering, 7 will come out. That is KCL. Kirchhoff current law did. 10 by 5, 2, in a passive element current enter positive. 10 by 2, 5, again passive element current positive. So 2, 5, total 7 entering, 7 should come out. Na? So in KCL, all incoming currents equal to outgoing currents. So in KCL what happens, sir? All incoming currents equal to outgoing currents. So clearly 5 plus 2, how much is entering? 7. 7 should come out. But when 7 is coming here, V is IR, so V0 is I into R. 7 into 3. Answer is 21 volts. Answer is 21 volts. 7 3s are 21 volts. Okay? Okay? So answer is 21. Don't say it is something all are parallel, please. No, how can they be parallel? Okay? Be careful. So answer is 21 volts. Now look at this, sir. This is another important question which came, and here checking the property of ideal current source. See this question. If R is 2, I is 5 amperes. Now if R is 5, I is how much? Okay? If this R is 2, I is 5 amperes. If R is 5, I is how much is asking. So first of all, this R is redundant or not? This R is redundant. Redundancy, unnecessary, waste element. Why? Because current source in series to any element, current is constant. Current source in series to any element, current is constant. You all accept or not? Yes. Current source in series to element, current is constant. So whether this is 2 or 5 or 100 or 1000, until here how much current will come? 10 only will come. Whether it is 2 or 5 or 100 or 1000, until here how much current will come? Until here 1000 only, 10 only will come. So until here 10 is only coming. So whether R is 2 or whether R is 5 or R is 100 or R is 1000, this will never get affected, because this side nothing changed. So previously when R is 2, if this current is 5, now if R is 5 also, this current will be 5 only. What is the reason? The reason, this resistance is a redundant element. Okay? This resistance is a redundant element. What is the meaning of redundant? Unnecessary. It may create only losses, that's it, but it will not affect the, it will definitely not affect the series branch current, because current source in series to any element is called redundant. This branch current will never change. This side, however, resistor never changed. So whether it is 2 or 5 or 100, this branch current will never change. This path resistance never changed. So if R is 2, also this is 5. If R is 5 also, this is also 5. Answer is how much? 5 amps only. Okay, that is the property of what? Ideal current source. Now this is also another interesting question. You see, sir, how good this question was. The voltage element absorb power, find current I. The voltage element absorb power, then find current I. He gave some options. In this I am stressing options because in this ISRO bit, option will decide something very interesting. In this ISRO bit, options will decide something. Let us see that. So see, he said this voltage element absorb power. Now if this voltage element absorb power, tell me common sense, it is sink or source? Absorb power means sink. So if this voltage element absorb power, it is sink. So that means sink means current should enter positive. Out of 12 ampere, some current is entering here. Out of 12, some current is entering. So this current should be less than 12. This current should be less than 12. So out of 12 amperes, if some current is entering, this current should be less than 12. Okay, out of 12 ampere is some current is entering, this should be less than 12. So out of option which is less than 12, 10 is less than 12. Okay, 10 is less than 12. Okay, yes. Okay, out of 12 some current is entering, this should be less than 12. Less than 12 is how much? 10. This is 10 amperes. Okay, na? Yes, understand. Now here what is L total? What is L total? Okay, now I need L total here, looking from here. Okay, now I need the equivalent inductance seen from here. Now this is not shorted, please. So reduction techniques first let us do, sir. Chalo. Now in that regard, let this be A, let this be B. Okay. Now this is junction. Now with respect to this junction and this junction, these three are parallel, na? These three are parallel. Okay, if you observe, sir. Okay, between this node and this single node A. Until here this is only A only, please. If this is B, until here this is B only. Okay. So between this node and this A node, this L are parallel. L by 3 it becomes, yes or no? So that will become L by 3. I will write here. L by 3. This is of course our A. Okay, and this is the center node. Okay, this is the center node. And these three L parallel. This is our A. So I wrote L by 3. Again, this is B, and this is between this node and this B node. These three are also parallel. L parallel is again how much? L by 3. So again with respect to B and this center node, okay, this is B, this is also L by 3. Okay, this is the center node and this is B. So L parallel L by 3. Now there is one L between this center node to center node, and there is another L between A and B. Another L between A and B. Now clearly we know these three are in series. These three are in series. How much? L plus 2L by 3. It is 5L by 3. Yes or no? Yes. Okay, if you observe, these three are in parallel. Okay, these three are in parallel L by 3. These three are also parallel L by 3. Then these three are in series. That is 2L by 3 plus L. Okay, is 5L by 3. Now finally this 5L by 3 is in parallel to L. So final LAB will be L in parallel to 5L by 3. So LAB is this into this by this plus this. If you see that, it is 5 by 8L Henry. Yes or no? This into this by this plus this. If you see 5 by 8L Henry will come. Okay, na? Now this is an interesting question. Again this model came many times. See this question. Find the steady state currents in each inductor and energy stored in each. Okay, find the steady state currents. I know I gave a switch. It represents transient operation. But is in ISRO, he is asking determine the complete expression for current. I don't think so. He is not asking like that. He is asking steady state currents and energy. Transient is over. You know, transient over in 5 time constant, any system reaches steady state, almost steady state. So yes, switch has closed, transient will occur, and after 5 time constant it reaches steady state. So because he is asking steady state means t tends to infinity, settled value. Now in t tends to infinity in steady state, inductors act like short. In t tends to infinity steady state, inductors act like short circuit. So if you observe, yes, inductors act like short circuit. Chalo, if you observe, yes, in steady state, yes, inductor acts like short. Then in short, you know, yes, this is shorted, switch has closed, and this is also shorted. Now this 1 ohm is completely redundant. 1 ohm becomes complete. So how the circuit becomes, let me show you. Because that is shorted, this is the 60 volts, this 1 ohm is completely shorted, this inductor is also shorted, okay, and that inductor is also shorted, the switch has closed, and of course here 2 ohms is there, here 2 ohms is there, okay, here 2 ohms, this inductor is shorted, okay. Then here what happened, that inductor is also shorted, then switch has closed. But why I am eliminating this 1 ohm? Because it is completely shorted. Passive element completely in parallel to short circuit is redundant, okay. See, this is one inductor shorted, this is second inductor shorted, this is third inductor shorted, but switch has closed. Please understand. Steady state, switch has closed, and in steady state, this inductor shorted. Now this 1 ohm is completely shorted now, that is why they are redundant. What is the reason I removed one? Because this is completely shorted. However, this is 6 ohms, 3 ohms, this is 6 ohms, and this is 3 ohms, and this is 60 volts. Chalo, I want the steady state currents. Now what is the total resistance in 6 in parallel 3 to 2 plus 2 4 ohms, 60 by 4 how much it is? 15 amperes. This is also 15 amperes. Now 15 amperes after coming here, these two are parallel, current division rule. If you do current division, this current is total 15 into opposite by sum, this is 10 amperes. 10 amperes. Okay, 10 amperes. Okay? So now if you see, yes, the steady state currents are 15, 15, 10. The steady state currents are 15, 15, 10. Now energy also is asking, energy stored in each inductor. So energy in 2 milli, if you observe energy in 2 milli is half L I square. I square is how much? 15 square. That is how much? 225 millijoules. Energy stored in 1 milli, that is also half L I square, 112.5 millijoules. And energy stored in 3 milli, half L I square, that is 10 square, that is 150 millijoules, 150 millijoules. Okay, 150 millijoules. Okay, so this is a steady state currents and energies, of course. Okay. Now voltage current plot in a passive element is shown below, then determine the component. He is asking voltage current plot in a passive element, determine the component. So he is indirectly asking Ohm's law. Let us check it. Now can this be resistor? See, if you observe the three passive elements, we know in resistor V equal to IR, in capacitor V is 1 by C integral I dt, and inductor V is L di by dt. First of all, can this be resistor? No, resistor is a homogeneous proportional component. Resistor is a homogeneous proportional component. If voltage is like a pulse, current also should be pulse. If current is ramp, voltage also should be ramp. So this is not a resistor because resistor is a homogeneous proportional, so it cannot be resistor. Similarly, can this be capacitor? Because in capacitor V is 1 by C integral I dt. V is 1 by C, integration of current. V is integration of current. If current is ramp, integration of ramp would be parabolic. Okay, if current is ramp, integration of current would be parabolic. But this cannot be even capacitor because V is 1 by C, integral of ramp would be parabolic. No. But what about inductor? Let us see. V is L di by dt. What is differentiation of ramp? Step. Differentiation of ramp is step. V is L di by dt. Differentiation of ramp is step. Okay. Differentiation of ramp is step. V is L di by dt. Okay. Differentiation of ramp is step. Yes or no? Yes. Differentiation of ramp is step. Differentiation of ramp is step. Okay. So this exactly matches how much? Inductor. Because from Ohm's law property, at least I can say it is an inductor. But how much is the value? Let us apply that Ohm's law. So this V is L di by dt. V is L di by dt. Okay. Now how much is the voltage? 2. L value I don't know. Change in current by change in time. Because it is a linear relation here. Change in current by change. What is the change in current? I final minus I initial. That is 2 ampere minus 0 ampere by change in time. What is change in time? 2 and 0. So 2 minus 0. That is also 2 minus 0. So if you observe, L is clearly how much? 2 Henry. L is 2 Henry. Later when current is constant, di by dt is 0, voltage is 0. Later when current is constant, okay, di by dt is 0, voltage is also 0. So it is clearly representing inductor. And how much is the value of inductor? 2 Henry. Okay. Now see this question. He is asking C total. Now is this a bridge structure? No, no, no. Be careful. Again such question suddenly, no, be careful. Be fundamental. This is not a bridge because there is no cross arm. In fact, it is a single node. This is a single node. It is not a cross arm element at all. So yes. So these two are parallel. In capacitors parallel is 2C. These two are also parallel. 2C. 2C, 2C series. Answer is C. 2C, 2C series. Answer is C only. Okay. Now see this very interesting question, sir. This came in GATE, it also came in ISRO. Same question came in ISRO. Now he's asking what is CXY, capacitance between them. But there is an interesting observation. This is an application coming from cables. It is an application coming from underground cables under fault condition. Now see this. This is 0 volts. This is grounded, fault, due to fault. This is 0 volts and this is also grounded due to fault. That is 0 volts and this is also grounded due to fault. Now if you can identify such nodes which are at same potential, you can virtually join them. If you can identify such nodes which are at same potential, you can virtually join them. Okay, if you can identify such nodes which are at same potential, you can virtually join them. So that is the reason I am joining them. So once you join them, if you observe carefully, between this node and this node means same as this node. Between this node and this node, same. This I can write here in parallel or not? Yes, if you observe. Now this is already CC. This is X, this is Y, this is CC. Okay, between this node, because this node is same as this node, this also will come in parallel. So this become how much? Yes, that CS will come here. So CC plus CS. It becomes what? CC plus CS because it parallel. Again, if you observe, because this is the same node as it is at same potential between this node and this single node. Okay, between this node and this single node, this CC and CS again become parallel. You can write here. So this also become parallel. CC plus CS. Okay, and however, this is ground reference. Doesn't matter. When you are calculating between X and Y, this ground will not do any any impact because it is a floating terminal. Maybe this is connected to the ground, but I am asking capacitance between these two. This will not have any effect. If I am asking per phase capacitance with respect to ground, and ground will not have an effect. But I am asking capacitance between X and Y terminals, yes or no? So when I am asking between X and Y, so this ground will not have any impact. So these two become series. Okay, series you know. So finally this CXY will become, okay, these two are in series. How much it become? CC plus CS by 2 plus this is in parallel, plus this in parallel. So this CXY will be, okay, so this become total 3cc plus CS by 2 farads. 3cc plus CS by 2 farads. Okay, 3cc plus CS by 2 farads. Okay, that is the answer we get. Okay, so this is a very interesting reduction. It is an application coming. But what is the reduction here? In any complex network, if you can identify such nodes which are at same potential, you can virtually join them. You can virtually join them. Now convert this network from star to delta. Now I want to highlight this. Star delta, delta star transformation in capacitor is also similar to resistor, but you have to reciprocate every term. Let us say this is some Cx. I want to highlight this. Let us say this is Cx. But same formula like resistor, but reciprocate every term. Like 1 by Cx is 1 by Cx is, okay. This plus this, but you reciprocate 1 by 1 plus 1 by 2 plus this into this, but reciprocate 1 by 1 into 1 by 2 by opposite 1 by 3. So this is nothing but 3 by 2 plus 3 by 2, it is 3. So if 1 by Cx is 3, Cx is 1 by 3. Cx is 1 by 3. Okay. Similarly, you do, this will be Cy and Cy will be 1 farad. And similarly, if you do, this is Cz, this is 1 by 2 farad you will get. Okay, 1 by 2 farad. You do it this way. Okay. You do it this way, you will get it. Okay, that is 1 by 3 you will get, here 1 by 2. But remember, same like resistor formula, but reciprocate every term including the left hand side. Now this is a famous model, sir, I want to highlight this. Now see, it is a parallel plate capacitor where he is inserting dielectric between these two metallic plates, but up to half area full distance. This is a parallel plate capacitor, he is inserting dielectric material of relative permittivity epsilon r up to full distance but half area. Now here you know this arrangement is like two capacitors where their working voltages are same but displacement currents are unequal. Why displacement currents are unequal? Because this is a dielectric material with relative permittivity epsilon r. More charge will accumulate here. More charge accumulate here, less charge accumulate. Due to which the displacement currents in the medium are different. Working voltage is same. So this arrangement is a conclusion. Here working voltages in both the mediums are same, but the displacement currents are not equal. Why the displacement currents are not equal? Because the permittivities are not equal. Because permittivity is not equal, the charge accumulated in this area and this area are different. So the displacement currents are different. Now voltage equal, current unequal means series connection or parallel connection. See, voltage equal, current unequal means this is parallel connection of capacitors. Parallel connection of capacitors. Now in parallel connection of capacitor, total C is how much? C1 plus C2. So CAB will be C1 plus C2. What is C1? epsilon naught, epsilon r for air is 1, A is A by 2 D plus, that is another medium, epsilon naught, epsilon r, okay, A is A by 2 D. So this if you see, the CAB if you see, that is epsilon naught A by 2D into 1 plus epsilon r, 1 plus epsilon r, okay, 1 plus epsilon r, okay, that is the meaning here, that is the meaning. Now here also if you see, yes, what is CAB, if you see here what is CAB, I need total capacitance between A and B, okay, but here you see this arrangement. When you place a dielectric material of relative permittivity epsilon r, now this time we are extending to full area but half distance. So because it is full area, the overall charge density uniformly increases throughout the area. Now this is like an arrangement when you give voltage, the voltage drops are unequal because this is air medium, this is some dielectric medium. Voltage drops cannot be same, but because charge has uniformly increased throughout the area, okay, charge has increased, the displacement currents in both the mediums are same. So here the concept is the displacement currents in both the mediums are equal as the dielectric material is spreading throughout the area, but the working voltages are different as the permittivities are different. So voltages are not equal. Now what is this connection? Displacement currents equal but voltages not equal, means this is series connection of capacitors, series capacitor. But in capacitor series you remember C1 C2 by C1 plus C2. So this total CAB will be C1, this part epsilon naught, epsilon r for air is 1, A by D by 2 into C2 epsilon naught, epsilon r, A by D by 2 by C1 plus C2, epsilon naught A by D by 2 into 1 plus epsilon r. Okay, now you can remove this, you can remove this. So this CAB will be 2 epsilon naught epsilon r A by D into 1 plus epsilon r. Okay, 1 plus epsilon r. Okay, this is the answer. Okay, remember sir, but understand the meaning. Previous model, the dielectric is spreading complete distance but half area, displacement currents are equal, voltage equal, that is a parallel connection. Parallel connection C1 plus. Here in this model, the dielectric is spreading throughout the area, so displacement currents equal but voltage drops unequal. Okay, so this is like series connection. Okay, then you see this interesting question: what is the nature of current I of t and also find the values of voltage V1, V2? Simple sir. What is the nature of the current? We know capacitors will never allow sudden change in voltage. Capacitors will never allow sudden, but if you do give sudden voltage, impulse current. See, I is C dV by dt. Okay, so the same thing, I is C total into delta V, that is like V final minus V initial by delta t. So I am giving like sudden voltage. How much is the voltage? It is like step voltage of 6 volts. So I is, now what is C total here? C total, if you see C total, these two are in series now, 2 and 1 in series is 2 by 3 into change in voltage. What is I V final 6, V initial 0. So V final 6, V initial 0 by delta V. What is delta t? Delta t is very small. Delta t is very small. So if delta t tends to 0, this becomes impulse current. If delta t tends to 0, this becomes impulse current. So how much is this impulse current? I is, okay, clearly how much it is coming? 4 delta of t amperes. 4 delta of t amperes. I is 4 delta of t amperes. Okay, answer is 4 delta of t amperes. That is the meaning. Okay, 4 delta of t amperes. Now see this very interesting question, sir. See this question. This is a problem on what? Can you tell me? This ammeter A is reading 10 amperes, A1 is reading 8 amperes, then A2 reading. So this is clearly sinusoidal steady state, sir. Sinusoidal steady state. Now in sinusoidal steady state, applying KCL is not just algebraic sum of currents, phasor sum of currents. But phasor sum of currents include both amplitude and phase. So let us draw the phasor diagram for here. So this is a series circuit or parallel circuit? Parallel circuit. Now in parallel circuit, what is better to take as reference? Voltage. So I will take voltage as reference. With respect to voltage, which current is in phase? That current in resistor is in phase. How much is that resistor current? A1. A1 is how much? 8 amperes. This is 8 amperes. Now what about the voltage in a pure inductor? In a pure inductor, current will lag voltage by 90 degrees. Current will lag voltage by 90. So with respect to voltage, current will lag by 90. Okay, current will lag. How much is that? We need to find that. This will lag voltage by 90. This is IL. Then according to KCL, IR plus IL is how much? Total current. That is how much? 10 amperes. That is how much? 10 amperes. 10 amperes. So now if you apply Pythagoras theorem, this current is root of 10 square minus 8 square root 6 square, 6 amperes. It is how much? 6 amperes. Okay, 6 amperes. So the reading of ammeter A2 is how much? 6 amperes. Okay, reading of ammeter A2 is 6 amperes. That is no doubt. Reading of ammeter A2 is 6 amperes. Okay, that is the thing. Chalo, but let me phasor sum. It is not algebraic sum. Now here if A1 is reading 6 amperes, next question. Okay, A1 is reading 6 amperes, A2 is reading 16 amperes, A3 is reading 8 amperes. Then what is this total current is asking? What is this total current is asking? Okay, na? Okay, what is this total current is asking? Again, sir, don't say the algebraic sum. Don't say 6 plus 16 is 22 plus 8, 30. No. Phasor sum here. Again, let us draw the phasor. Again, series or parallel? Of course, it is parallel. In parallel, again, I will take voltage as reference. Now, with respect to voltage, which current is in phase? Resistor current. That is 6 amperes. 6 amperes. Next, what about the current in a pure capacitor? In a pure capacitor, current will lead voltage by 90. So, lead by 90, which is 16 amperes. Lead by 90. Lead is anti-clock. This is 16 amperes. Then what about the current in a pure inductor? In a pure inductor, current lags voltage by 90, that is 8 amperes. Current lags by 90, it is 8 amperes. 8 amperes. Now, if you apply KCL, IC plus IL, if you cut here, this will be again 8 amperes. This will be 10 amperes. Okay, so 10 amperes. So overall current is how much? 10, because IC plus IL I got, plus IR is total current. So finally, ammeter A is reading how much? 10 amperes, not 30, please. Okay, and moreover, find the total supply power factor. Now power factor is cos of phase angle between, power factor is cos of phase angle between total voltage and total current. Here, which is total current? Ammeter A current, and total voltage is the reference. So with respect to total voltage, this is the phase angle phi. This is the phase angle phi. So yes, that cos phi is adjacent by hypotenuse. Adjacent 6, hypotenuse 10. So answer is 0.6. Leading or lagging? Leading. Leading. Answer is leading. Okay, overall 0.6 leading. Okay. Now here find current I in the circuit shown below. Find current I in the circuit shown below. Also find input power factor. Okay. Find current I in the circuit shown below and also find the input power factor. Okay. Chalo. Now again, to find this current, let us draw the phasor diagram. Okay, very interesting, sir. Because he did not give the value of XL and XC. If you would have given the value of XL and XC, yes, I would have directly used Ohm's law, I is V by Z. But he did not give that. Okay, then what to do? Let us draw the phasor diagram. Again, sir, this is series or parallel? Series. This time I will take current as reference. So with respect to current, which voltage is in phase? VR, which I don't know. VR is in phase. Now what about the voltage in a pure inductor? In a pure inductor, current lags, or with respect to current, voltage will lead. This will be VL. And VC, with respect to current, voltage in a capacitor will lead. Sorry, current will lead, voltage will lag. That is VC. But how much is this values? Both values are equal, because that is 200, this is 200 now, both are equal. They phase cancel. Now if you apply KVL, you know phasor sum of VR plus VL plus VC is V. Yes or no? The total V is 100. So VR plus VL plus VC is V. But VL and VC are two equal opposite phases. They cancel. So VR itself is V, and the angle between total voltage, total current is 0 degrees. So now we know, yes, this IR is VR by R. Okay, Ohm's law, VR by R. But VR is V, because VL and VC are together acting like short circuit, they are phase cancelling. So VR is V by R. But what is V? He gave 100. Okay, R how much he gave? 20. So IR is 5 amperes, which is of course equal to I. IR is 5 amperes, which is of course equal to 5. IR is 5 amperes, which is of course equal to 5. Okay, of course equal to 5. Okay, na? Yes, that is IR. And then input power factor is cos phi. Cos phi, that is cos 0, 1. Unity power factor. Unity power factor. Okay, cos phi, cos 0, 1. That is unity power factor. Okay? Yes, that is the meaning. Then what is the power absorbed by the resistor? Okay, this problem is asking what is the power absorbed by the resistor. Now resistor will dissipate energy in the form of heat or not? Yes, resistor will dissipate energy in the form of heat. So heat means RMS values. So to find power lost, yes, power lost is I RMS square into R. Now what is IRMS for this? K by root 3. K by root 3, remember that. Okay, K by root 3 square into R. But what is this K? Maximum value. So that is 6 by, this K is the maximum value, 6 by root 3. Let me correct it. Root 3 square into R. Of course, R is how much he gave? 3. So why RMS is important here? The question here is why RMS is taken? Because resistor will convert energy in the form of heat. Okay. So RMS is the heat equivalent of any waveform which I told you. Okay. So RMS. So this is nothing but 36 bits. So minimal calculations are, he will not trouble you much. Gate bits are slightly deeper in calculation unlike ISRO. But ISRO, there may be calculations are not tough, but they are very logical problems. Okay. But here RMS is important because heat equivalent IRMS square into R. Now this model I want to highlight. He gave a voltage function. I want to just give the data here. Okay, you do the calculations. But yes, if V is this function, okay, 8 plus 20 sine omega 1 t 25, 10 cos omega 2 t minus 25, find V average, VRMS if omega 2 is to omega 1 and VRMS is 1. Let us take each case. First of all, case A, what is V average? V average is the DC component, 8 volts over. V average is the DC component. Second case, omega 2 is to omega 1. When omega 2 is to omega 1, it becomes Fourier series. Now this becomes Fourier series. In Fourier series, what is the value of VRMS? In Fourier series, the value of VRMS is root of, yes, 8 square plus 20 by root 2 square plus 10 by root 2 square. That will be the VRMS. That will be the VRMS. Okay, that will be VRMS. Then if omega 2 equal to omega 1, if omega 2 equal to omega 1, now that is not Fourier series, sir, be careful. When two equal frequency phasors are there, it is not Fourier series. When two equal frequency terms are there, it is not Fourier series. When two equal frequency terms are there, then it is not Fourier series. Okay? It is not Fourier series. So when omega 2 equal to omega 1, when omega 2 equal to omega 1, then it is not Fourier series. Okay? Fourier series. Then what to do? You have to add the phasor. Then this voltage function V of t become for this C bit. Okay, 8 plus, this is like 20 angle 25 plus, this is 10 angle. Now this is 90 minus, because cos and sin are given, phase shift of cos theta is sin 90 plus theta. So 90 minus 25, yes, 90 minus 25 is how much, sir? Because cos theta is sin 90 plus theta. Okay, that is nothing but somewhere around you are getting how much? 65. Yes or no? Yeah, so what I want to say is, sir, see the difference. First, V average is the DC component, that is 8. VRMS is how much? For this, when two different frequencies, that is directly Fourier series, maximum by root 2, maximum by root 2. Their phase shift is not a matter. But third bit is very interesting. If two equal frequency terms are there, that is not Fourier series. Then we have to add the phasor. When we are adding phasor, then this phase shift is very important. I better convert both into sine or both into cos. RMS value will come same. So what I will do, okay, I will write this cos theta as sin 90 plus theta. This I will write it as 10 cos theta is sin 90 plus theta, that is omega 1 t minus 20. Okay, na? So that is nothing but somewhere 90 minus 25 you have to do. Okay, 90 minus 25, how much you are getting? 65. Okay. Okay. 90. So now we have to add this phasor, sir. This you do now in calculation. That is why I am not doing here. I am leaving you. Now if you add this, okay, let us say you got some approximately. I will give some dummy values. Something you got like Vx angle phi x. Let us say you have to use calculator, sir. Okay, converting first of all polar to rectangular, add and convert back to polar. Now this is again still maximum value. This 20 and this 10 are what value? Maximum value. So this is also maximum. Then you will get the final VRMS is after adding that root of 8 square plus this Vx. Okay. Yes, plus. Okay, let me correct it. This is 8 square plus. Okay, 8 square plus whatever this Vx you get now by adding. Yes, that Vx by root square. That is what you will get. Okay, that part I need, but I want to show the difference in three models. Average value is the DC component. If two frequencies are different, that is Fourier series. If two frequencies are equal, that is not a Fourier series, then you have to add the phasor. But while adding phasors, sin and cos phase shift is very important. Cos theta is sin 90 plus theta. Okay, 90 minus 25. Okay, 90 minus 25 that you have to do. Okay, now sir, like that there are very good bits. There are very, very good bits. Okay, my intention is to give confidence here. Okay, this is another problem. See this question. Let us also see after this session. I will talk something very important for you. See, Now in this question, current I of t he gave and load impedance he gave. Okay, then find the average power, reactive power, total power. Now this comes under which case, sir? Because in calculating powers, okay, sinusoidal to linear load, because this is sinusoidal current only. Sin or cos is called sinusoidal, but what is the load? R minus XC RC. So sinusoidal excitation to linear load. So this is a normal network. Now what is active power or average power? It is I RMS square into R. That is 5 by root 2 square into R. R is the real part, 4. That is how much it is coming now? 50 watt. What is reactive power? I RMS square into X net. That is 37.5 watts. Now what is apparent power? I RMS square into Z. 5 by root 2 square into Z. That is 5. 62.5 Vs. Then what is the power factor? Cos phi. Yes, power factor cos phi is R by Z. R is this, Z is pi. That is 0.8 leading. Why it is leading? Because overall reactance negative. Negative means RC. Okay, negative means RC. Okay, so see, the intention of this 1 hour is not to give everything, sir, which is not possible. But see, join our ACE online course. Okay, always we will be there, and also our offline courses are still available. Plan properly, and we will be always there, because achieving such great exams, you do require not only your self preparation but proper guidance. And in ACE Academy and in ACE Online, we are there here to do that. And we are since many years in this field, so we accurately give you the data and relevant things. So my suggestion is, please do join our institute. But right now concentrate in doing PYQs of gate bits, IES, ESC, engineering services bits, and ISRO bits. ISRO bits are equal to gate standard but less in calculation. Calculations are a little bit easy. Now what I suggest is, all the students who are watching this video, who are my ACE Academy students, previous students, okay, whoever is watching, I will give my WhatsApp number. Please only WhatsApp me. Don't call me directly. I won't lift any new number. But my name is Krishna Varma. Okay. Okay, my name is Krishna Varma, BS Krishna Varma, faculty in ACE in Network Theory, and my WhatsApp number is 9000616124. Okay, 9000616124. For this exam, which is hardly 2 to 3 weeks, maximum 3 weeks, every possible help I will do you. Even the doubts, etc., what you are getting in networks, you just take the screenshot and put into my WhatsApp. I will immediately reply to you. And whatever material I can give you relevant, my personal notes, etc. But the official commercial material you have to buy from ACE Engineering Academy. Our ACE publication section is there. Contact them through Flipkart, Amazon, okay? Or our publication section is available in Kottapet, okay? And also in Habits. You can directly approach them and buy these books immediately, okay? So, yes, this is only to inspire you, to guide you, sir, okay? But all the best. Don't give up. My first suggestion is, don't give up until you come out of the exam hall. It is enough. You can beat 99% of the competition. Okay. Whatever your fundamentals, go through them and do only PYQs of gate, IES and ISRO bits directly. That too topic wise, like network theorems, all bits, transients, all bits, resonance, all bits, control system, Bode plot, all bits, signals and system, Fourier transform, all bits. That is more than enough. Okay. So all the best. Contact me through WhatsApp. I will be always there to help you on priority basis, because your exam is hardly 2 weeks. Okay. Thank you.